In this video, we're going to be talking about calculating distance rasters. Now, distance rasters in ArcGIS are referred to Euclidean distance. In QGIS, they're referred to as proximity rasters. They follow the same principles. That is, on a grid with an X and a Y, which is what a raster is, we can calculate the distance from any point to the other with some very simple Euclidean geometry math. On the X and the Y purely, very easy to count the number of cells away that you are and translate that into distance. On the D, on the diagonal, we use the simple Pythagorean theorem to calculate the distance from one grid cell to the other. Now this plays out like this. Our inputs to proximity functions in QGIS is a source raster, where our sources, or the input data that we want to find distances away from, have a value, could be any value, and all the other grid cells in that raster contain no data. When we run that proximity tool, what QGIS does is it calculates the distance from that source cell to all other cells on the map. Now, straight across in the X and Y, this is pretty straightforward to measure, right? It's just 1, 2. However, if we want to go on that diagonal, how are we going to get that? Well, we're going to use some classic old geometry, the Pythagorean theorem. C squared equals A squared plus B squared. So to get the value of 2.2 here, we simply take the square root of 1 squared plus 2 squared. Similarly, for the value of 1.4, the square root of 2. The value of 2.8, the square root of 8. This same math applies if we have two source cells on our raster. Look at what happens here. We have values of zeros in the corners. Along the X and the Y, things are pretty straightforward. And at the centers, things get a little bit more complicated. So essentially, we end up having overlapping areas where this point here is evenly split between these two. This cell is closest to this cell, and these two values here are evenly split between these zero cells as well. Let's go over to QGIS, and we are going to look at the location of steward shops around Saratoga Springs. We're going to run a distance surface to see where in our area are you furthest from a Stewart's. Now, obviously, it's much easier to get to Stewart's with road networks than it is to cut across the wetlands of the Daniels Road State Forest, but we're just going to keep this simple analysis for our purposes here. So I'm going to go to my processing toolbox. I'm going to search for proximity. It's here under GDAL raster analysis. Okay, so for my input layer, I'm going to select Stewart shops. You'll notice that this Stewart shops is a rasterized version of this point Stewart shops data. And we need raster input data as our source data for running proximity within QGIS. Distance units are going to be pixel coordinates. We can leave these as zeros. And then let's save our proximity map as dist Stewart's .tiff. I'm just going to run that. We get something that looks like this. We're going to need to go into layer styling and modify that from single band gray to single band pseudo color. Let's invert that. I'm going to make this quantile, just make it pop a little bit more. And let's make it a little bit transparent here so we can see what's going on underneath. So what we see is those places in blue on the map are places that are close to Stewart's. Places in yellows into reds are places that are far away from Stewart's. Let's add our Saratoga boundary on here, and we can zoom in and just sort of see places that are a little bit underserved by Stewart's. Some spots here on Lake Avenue could really, maybe they'll put a new Stewart's in there. Maybe down here on Union somewhere. I really thought we had enough Stewarts in town, but looking at it here, maybe we need a couple more. All right, that's distance raster tools using proximity. Catch you in the next video.